Hello, I'm Dr. Dimantha De Silva, the transport planner and the modeler for the consultancy service for the feasibility study and the detailed design of Colombo Suburban Railway project. I want to set the record straight on several facts and information that could be considered misinterpreted and distorted, which were presented to you during a public seminar that was held on 5th September 2019 by the Transport Committee of Institute of Engineers Sri Lanka on the title The KV Line Railway Optimization of the Design and the Cost, where a video has been circulated in social media and several seminars have been held recently by the same group of presenters. I would like to provide to you the facts extracted from the detailed feasibility study report available if you want to look into it, and to show that this group of presenters who have done similar attempts in major development works such as expressways have purposely misled the audiences and continues to mislead the audiences, maybe for their own personal agendas. Let's look at what was told to you. It was said that the consultants and the project management unit did not attend the seminar in question at the last minute. A convincing story was told with a notion that several versions of the feasibility reports were available and that were changed based on the lobbying of this group and without giving any reasons. Several alternative designs were presented by this group, although no methodology or supporting data were shared. An effort to convince that the PMU did not have enough capabilities and the question the knowledge of professional experts in the consultant team. What was not told to you, the reason for the PMU and the project consultants for not attending, then it was communicated to them well in advance. One of the main reasons was the agenda as shown not giving adequate time to the PMU to present to the audience. While 3 speakers from IESL was allocated, only 1 was allocated from the PMU. This was requested from the IESL to change by allocating more presenters from the project unit, including myself, but for some reason IESL did not want to change the agenda. Secondly, the timing was when resettlement plans were happening, and the PMU were in the opinion that a public seminar could hamper the process, and which it did. According to the PD of the project, this message was communicated well in advance to the IESL president and the secretary in a letter as shown here. And also, the day before the seminar, he had met them personally and requested to change the meeting time. So it is incorrect to say that the project unit and the consultant did not attend the seminar in the last minute. In addition, although I am a consultant to the project, I am also a senior lecturer at the Department of Civil Engineering at University of Moratuwa, attached to the Transportation and Engineering Division, which is the only place in the University of Moratuwa where transport engineers are officially represented at the University of Moratuwa. Although I was not invited for the seminar, I could not attend the seminar since the day that the seminar was questionably organized was the day university had its own transport research forum, the conference at the university organized by the university. So even if I had wanted to attend, I could not attend it. But the question is why the said date was picked by the organizers when their organizers and 2 of their presenters were well aware of the university conference, with them being one a council member and another a senate member of the university. What was not also told was that the institute member appointed to the steering committee was absent when all of the major decisions of the designs were made. They also failed to mention that there's only one version of the final feasibility report, and all the others that they mentioned were draft versions and that were submitted for internal circulations only. Also, they failed to mention that Before this seminar, several rounds of meetings were held between the same presenters and the project consultants, and all of the comments and questions shown today on this seminar were answered by the project consultants. So if I summarize the main issues raised by the presenters, the first one was that the project cost was initially estimated at 2.5 billion US dollars, and it was reduced to 1.5 billion just because IESL raised it. The second question was on the demand estimations. The third question was on the need for elevation of the track or the vertical alignment, and the counter proposal of elevating only 6 kilometers and at an estimated cost of 940 million US dollars. And the final question was the question on not straightening the line further or the horizontal alignment. All these were answered to them not once but several times, and I intend to show you all that the same facts that were shared with them before, so you could judge whether we have provided sufficient reply if someone is not prejudiced. To start with, let's look at the role of IESL in this project and chain of events that happen. IESL is a member of the National Project Steering Committee in PSC, but they are not a member of the Special Project Steering Committee. Engineer Dr. Tilak Siambalapitiya and Engineer Priyal De Silva were nominated as IESL representatives to the NPSC. However, Engineer Priyal De Silva withdrew from the participation later on. The first 3 NPSCs were held, but the next 3 were very crucial. You can see the 4th NPSC was held on the 16th of September 2017, at which the initial recommendation based on the pre-feasibility studies were presented by the consultants, where the heavy rail option and the elevated options were presented. However, the IESL representative, Dr. Siambalapitiya, was absent at this meeting, and he was represented by Engineer Mahesh Ratnakar, an employee of Dr. Siambalapitiya's consultancy company. There were no responses given on behalf of IESL. The 5th NPSC was held on the 16th February 2018, which was chaired by the Honorable Minister, at which the consultant provided the background why KV line needs to be prioritized. Dr. Siambalapitiya was absent again, and he was represented again by Engineer Mahesh Ratnakar. There were no responses given on behalf of IESL. The 6th NPSC was held on the 6th April 2018 and was a very crucial meeting where the consultants presented different horizontal alignment options and different vertical alignment option considered by them and made their recommendation for the selected option for the current selected trace and the option of elevation of the track. Dr. Siambalapitiya was once again absent, and he was represented again by Engineer Mahesh Ratnakar, and once again there were no responses on behalf of IESL. So these crucial decision is important, because at any design, any study, you need to make this kind of crucial decision at the early stage so that you can progress without any delay of the project. So based on the agreement of this proposal or the proposed design, the project consultant continued with the completion of the feasibility study, and the first draft version of that report was submitted on the 15th October 2018 and on the occasion of the 7th NPSC that was held. This is the so-called first feasibility report as claimed by the IESL, and this was the first time the project cost was presented to the steering committee. The project cost of 2.5 billion US dollars was presented by the consultants as an initial estimate. Ironically, it was the ADB experts and the project director of the PMU who actually first raised the question about the cost being too high. Dr. Siambalapitiya was also present on this day, and he too commented on the cost too being high. He commented his comments was only regarding the cost and not based on any other design alternatives. The team leader, Mr. Han of DOA, explained the basis of cost estimation, and he explained that the cost has been estimated based on international rates, and he continued to say that he expects the cost to come down by 30 to 40% with the cost rates adjusted to the local rates, and also with the detailed BOQ being updated with the completion of detailed designs. So therefore, it is incorrect to say that A, cost came down suddenly after 1 month. B, that it happened because IESL raised this issue. What is not told by the representative is that the team leader indicated on the same day that the cost is expected to come down when the final feasibility report is submitted. Also, you could see that the IESL representative was absent when all the key design elements were presented. And it was the first time a comment was raised by IESL, and the comment was only on the cost but not on any other matter. Subsequently, IESL makes a written submission of their concerns to the PMU, including concerns on the elevation and horizontal alignment. However, these were already agreed by the steering committee by that time. The consultants takes the suggestion aboard and submit an updated draft report on December 2018, which is kind of referred to as the second feasibility report by the IESL, and then submitted the final official version of the report on April 2019. Detailed explanations were given to the Transport Committee of the IESL over several meetings held with the PMU, IESL and the consultants. And in spite of these explanations given, a seminar in question was held as a public event with live link shared publicly, advertised publicly, and also uploaded into the internet where even you can download it today. Then one of their members, while attending a ADB Energy Forum in Manila, personally handed a letter complaining about the project to the ADB, which was copied to the Department of External Resources. To resolve the issue, ERD calls for a meeting on 13th of November 2019, chaired by the DG of ERD, with key stakeholders such as Ministry of Transport officials, Treasury officials, PMU, NPD, members of IESL, and the consultants participated. PMU answered all the questions that the IESL members had and also answered the content presented in this seminar. However, when the PMU members questioned the IESL members on the basis of their assumptions and the calculations made for their alternative proposal, they could not answer and could not defend any of their claims quantitatively when caught by the chairperson. The slides extracted from the PowerPoint presented at the seminar summarizes the concerns by the IESL. First, they tried to show that there were 3 feasibility reports which kept on changing each time a question is asked. The speaker's intention was to show the misconduct by the consultants. However, most of you who have been part of any projects or any study would know that the final report just don't come out at once. I have explained before the reasons for the 3 versions of the report and how it folded. These draft versions of the reports are usually produced in well-spaced time intervals, giving enough time for project units and the stakeholders to give their comments and to monitor the progress of the consultants. First of all, there's only one official version of the feasibility report approved by the ADB, PMU and the Ministry, and that is the report submitted on the 11th April 2019. Any of the other version of the draft reports were only available for steering committee members, and reasons for any changes between the internal documents have been provided to the steering committee members. It is unfortunate we are not speaking about the final report findings, but on the reasons for the numbers being changed in an internal document, and thereby making people confused. This is the very reason internal documents are not shared with the public. What is more concerning and unfortunate is that a steering committee member who have a responsibility of holding such position have forgotten the code of conduct and has released this confidential document to the public, creating these confusions. The real question is to you: do you trust these kind of people in the future? Do you involve them in next stages when more confidential documents such as tender evaluations are done? A thought that should be taken very seriously. The presenter showed that the change in cost, change in ridership, and change in EIR had happened in these reports. However, he does not try to any effort to disclose the reason we have provided to him. Therefore, during this presentation, I will present to you all these facts to your judgment. It is very childish that someone tries to claim that the cost reduction has happened because they highlighted it, which is a misinterpretation itself, and also try to claim that they have saved money to the public by doing so. However, what is more disappointing is a senior professional trying to accuse a donor agencies, a financial experts for the projects who have done a professional job, that they have manipulated the EIRR numbers so that to make the project feasible. Maybe they speak by experience, which we will look in next. So I looked into a report that the presenter had done as a team leader. And mind you, this is a final report, not the draft report, which is available on the web to download and check if I'm wrong. This study reports a whopping EIRR of 53%. That is very high, isn't it? One should be curious how you get such high EIRR. So when you look into detail, you find that the summation across all columns highlighted in red in the table only consists of addition of only few numbers as shown on the top right hand corner. Just for curiosity, when the full numbers are used, what we see that the EIR that comes out would be 298%. So if you look to find the reasons, it looks like someone who did this calculation had reduced the EIRR but forgot to change the table on the report as well. So surprise, surprise, we know who really do manipulated numbers, don't we? It was disclosed that the estimated cost was 2.5 USD billion. As explained before, when ADB and PMU raised the question on cost being too high, the team leader explained that the cost was estimated based on international rates and he expects it to come down by 30 to 40% with detailed designs completed and will be adjusted in the final report. He said it on the 9th September 2018, on the day of the first draft report was submitted, not suddenly after the 1 month or because of IESL question as misinterpreted by the presenter. The cost was updated on December 2018 report first and finally on the final report on April 11, 2019. The estimated final cost was 1.4 billion US dollars with a construction cost of 1.2 billion US dollars. The reasons for reduction explained by the team leader was for twofolds. A, it was due to refining of the initial cost done based on international rates and using the new local rates in detailed cost estimation with optimization of structures like bridges, stations and track works, and due to change in rolling stock cost. And then B, due to the present cost being the previous cost estimated was being done in LKR and converted based on exchange rate of 150 instead of 179. With both these factors combined together, the cost reduced from 2.5 billion to 1.4 billion, and these were during internal calculation, when the work was in progress. I hope it is very clear for all of you why these changes happened during the course of the study happening, not because that IESL raised it. Although for some people it cannot be digested. So let's move on to the questions on demand analysis. The presenter tries to show that the demand numbers have changed and there's no reasons given, and tries to add to the story as if the numbers are just made up. The basis for this accusation is that the demand numbers remain high on the so-called two reports, report 1 and 2, and suddenly had come down in report 3. When we do the demand modeling, we don't do one run. It goes through thorough scientific process, and this is a technique that is not many in Sri Lanka understanding that. So I will explain it in detail a bit later. Although we know what would happen now, what we don't know for sure is what for the future scenario. There can be many if and buts, and the demand numbers can change based on the many combinations of assumptions you make. So one such assumption is how you consider the population growth for the future. A high growth will have more demand, and a medium growth in population will have lower demand. Later on, you would see that this change in demand numbers was based on such assumption on the population growth assumed. However, all these model scenarios are well documented in the feasibility report, and therefore there are only two reasons that the presenter says what he says is either he has not read the report, or he has not understood the report, what is written in the report, or he does not understand modeling in general. The demand modeling designed for the rail demand depends on key three assumptions. The first is the operational assumption that includes the fare, the frequency, the speed, access time to train, wait time, the facilities, etc., which can be considered fixed normally. The second assumption is how you consider the socio-economic assumption, where you consider how your population and employment is considered to grow. That is, whether you consider a low, medium or high growth scenario. The final and third assumption is what other projects that will have an impact on the demand. The impact can be sometimes positive and sometimes negative. While the operation assumptions can be considered fixed, multiple combinations of socio-economic growths and other projects will create the alternatives that you consider for your modeling. There were two major development plans that were available during the study. The first development plan was the megapolis plan that considered the high population growth scenario of population growing from 5.8 million in 2013 to 9.1 million by year 2035. The second major development plan was the Comprance plan, which assumed a population growth in a medium growth scenario from 5.8 million in 2013 to 7.9 million by 2035. Therefore, the study used both of these assumptions and considered megapolis growth as high growth scenario and the Comprance growth as the medium growth scenario. This was the some socioeconomic assumptions used in the study. Three alternate modeling scenarios were considered in the study. Scenario 1 was a high population growth scenario but with moderate planned other public transport. This was considered as the high growth megapolis development scenario. The scenario 2 was still a high population growth but virtually no other public transport development, and known as the high growth, less public transport development scenario. Then the final scenario considered was a medium population growth scenario with the same public transport development considered under scenario 1. Should be noted that although there were only 3 scenarios reported in the final report, there were over 50 modeling scenarios considered in the study to look at the impacts. The above modeling scenarios were tested using a modeling process that I will describe to you next. What we really want to understand is the number of people or number of passengers that will use a rail network or the road network. The process used was called a 4-step method. The first step is called the trip generation, and in this step we determine how many people will travel to and from a particular area. What we get is called a trip table. What we use as inputs are the socio-economic information that we discuss, such as population, jobs, school children, etc. The second step is called the trip distribution. In here, we use the trip tables that was used, that was understood from the first step, and determine where are the people going to and from each area. We use previously done origin destination surveys, and the output is called origin destination matrix. The third step is called a mode choice. In here we calculate how many people would choose a particular travel mode. That is, whether they will use to go to their destination from their origin, whether they will use the car, the motorcycle, the bus, the rail or the LRT. This is where the comparative analysis is done, where the fare, travel time, access time, frequency between each of the mode will play a role, where people will choose a particular mode based on their perception. We use information gathered from surveys that tell us how people behave and basically break out one single OD into multiple ODs. This step, the mode choice, is one of the most important steps of urban transport modeling, especially when it is a public transport study. Now the final step is called assignment, and this is where people will choose what route they will use. And in the case of road network, we use highway assignment, and people will choose which road or route they will choose. In the case of public transport, we use transit assignment, and people will choose between 2 routes in a particular mode. For example, if it is a bus, they will consider whether they will use against route A against route B. The output will give us how many private vehicles will go on a road and how many passengers will go on a public transport. And this step is circulated through mode choice in couple of iterations. For a known year, when we have information, we would run the model and calibrate the model so that what we know is produced by the model. That is what we call calibration. And then we will run the scenarios that we talk about for the future and to understand what we don't know. The table here shows the summary of passenger demands for the 3 alternatives considered. Here the total passenger trips at the maximum section and the total passenger demand in the system is shown. At the initial stage, we considered the high growth scenario and reported that as the project scenario. This was because the megapolis was the government plan and therefore it had a higher demand as expected. But later on, based on the discussions with the ADB and the PMU, we decided that it is much appropriate to use the medium growth scenarios rather than the high growth scenario. And so you could see this is the reason for the change in the numbers of the demand. And that is why the demand numbers have gone down. For example, what was reported as 188,000 in 2025 in the maximum passenger section had gone down to 177,000. What was reported as 240,000 in 2035 had gone down to 202,000. Similarly, total passengers in the whole KV line network went down similarly, let's say for 2035 from 426,000 passengers totally to 366,000 passengers. And this explanation has been given to the presenter and also to the whole group and many times. So they keep on repeating that the reasons have not been given over and over again is a big question to me. There are two separate demand numbers which people sometimes get confused with. One is called the sectional volume and the other is called the total daily passenger trips. The sectional volume is the total number of passenger trips in a particular section. Usually we are interested at the section that has the maximum number of passengers. This is usually used to understand and used for our planning purposes. In this case, in the KV line, the section that has the maximum number of passengers was the Kiralapananu-Nugegada section. The number is used to calculate the passengers per hour per direction, or technically called the PPHPD. The number will determine how many passengers we need to carry during a peak time period, which will in turn decide how many trains per hour we will have to send. Therefore, this is an important number. However, this section does not include all the passengers in the system. For example, passengers having an origin and destination between say Fort and Borella, Fort and Narayanpita, Borella and Kiralapana, and Homagama and Nugegoda, etc. does not get counted in this section or the maximum section between Kiralapana and Nugegoda. Therefore, it is important to know that the total daily passenger trips is different from the sectional volumes. The total passenger trip is the aggregation of all passenger trips between all stations. And this will count all the passengers even going a short trip. Therefore, the total passenger trip number has to be always higher than the maximum sectional volumes. Now, so for this design, we used that the maximum section value in year 2025 was 177,000 with a PPHPD of 18,400, and for the year 2035 it was 201,662 with a PPHPD of 20,973. The total passengers in the KV line system was estimated as 274,000 in year 2025 and 366,000 in year 2035. This is very common for some people who might not have a knowledge of modeling to get confused with this definition and mix these numbers. Once again, this is a slide extracted from the presentation at the seminar. Here the presenter tries to compare the modeling work results by me and him. Unfortunately, he only shows the year 2025. Maybe he has not run 2035 at all, or we are made to believe that he has not even run 2025 as well. He starts that in comparison to my estimate number of 177,000 for the maximum section volume between Kiralapana and Nugegoda, he gets a number of 196,998. However, he conveniently avoids showing the total passenger number he gets. This is understandable as this is the hardest calculation that you need to do manually, going through a 476 by 476 matrix. And if you really don't know what the model is doing, it will be very hard to show it. Knowing the people who does the work for him and knowing that they don't get any guidance, it is understandable that they have omitted this number. The presenter tries to mislead people that the same model is being used and goes on to say that if two engineers use the same software, the same model and the same input, they should get the same results. You need to understand that the model is a process and the process is enacted inside the software. Therefore, the model and the software is two clear components. The software used by both maybe is called the Strada software. Everything you use, sometimes the software, even though you use the same software, if the process used is different, you will have different outputs. And we know for sure the process he uses is totally different to the 4-step process that I have explained to you in detail before. You can remember, I explained the 4-step model and explained that the mode choice component is the most important step in a public transport modeling work. What I will show you next is how the presenter have considered the approach based on the documentation of his work. You can go through this document where the assumptions in the process he uses is documented. First of all, the OT tables are modified based on expert value. And it is not based on population or employment change. This is one of the hard-coded assumptions that is being made. Secondly, the mode choice component, which is very important in a public transport study, is omitted, saying a cube software was not available and due to limited time of the study. Mind you, this study in question took over 1 year, the study that was done by this presenter. And also, when we did the mode choice, we didn't need this cube software, but only needed the knowledge of mode choice modeling, and that is what we used. So let's look at what are the assumptions that they have used, and what was shown before was the excuses given for not using, right? So the assumption they have used is to hard code the numbers to say, when we are developing a public transport, if you are making a bus lane or a BRT, right, or a railway line, what was assumed by him was that 10% of the car users, 30% of the motorcyclists, 20% of the three-wheeler passengers will change to that particular public transport use. And so this is a very hard code assumption. Right? So this actually can lead to writing the answers. In other words, if you want more demand, you can increase this share by a certain number. If you want lower number, you can decrease this share. So these are what the numbers that he uses that are not sensitive to any changes in fare, frequency, travel time, or even other particular projects that are happening around. So it's a very clear why we get a EIRR of 298% before, as discussed, because these are based on hard-coded assumptions. So bottom line is, I really don't expect, even he uses the same inputs, he will ever get my results, considering that me and him uses two different processes in modeling. The flawed process described to you was applied in the work that is presented in this report shown here, which is the Transport Master Plan made up by the same presenter. Recently, we have seen that he is on a roll to promote back this same plan, citing COVID as an excuse. Therefore, we should really take note of these flaws in analysis and should at least review through an independent body if we are even to consider anything from it. Now let's check whether the numbers presented by him really makes any sense. He states that he gets 196,998 for the maximum section between Kirulapan and Nugegada, and that is a share of 30% for the rail from the total corridor. And this is from extracting from his own slides. And if 196,998 is 30% of the total corridor volume, then the total corridor passengers, that is 100%, is 657,000. I hope you agree with me. He estimates total number of passengers passing Kiralapana by car, by bus, by train and all other modes will be 657,000 by year 2025, not 2035. The number we have surveyed in 2012 is 175,000. So what he's saying is there is 11% growth per annum by all the trips that's happening. What we estimated for the year 2035 in the medium growth scenario was 354,000. And even for the high growth, it was 419,600. But the same presenter made a big fuss when we had met in previous meetings, saying that our demand estimations are very high and overestimated. And here he goes and estimates a total corridor demand of 657,000 for the year 2025. So, which is even higher than the high growth scenario of what we have estimated for the year 2035. So there's something terribly wrong here with his estimations, and which in fact we wanted to check whether we had made a mistake and requested him to provide his calculations and model by officially writing to the university, since the model that he has been using was at the university provided by the Ministry of Transport for a previous project that he had done. But unfortunately, he has been avoiding to provide the information, and he has replied saying that this work was done as a private work for IESL and not done as part of the university. So that is again a questionable thing. The bottom line is this belief, we are made to believe that the so-called modeling work done by his team never really happened. But the numbers shown to you in this graph are just a set of numbers displayed for the presentation purposes. The graph shown here, used by the presenter, tries to mislead the audience with a distorted graph. And here he is using numbers picking up from different alternative scenarios. Then he tries to justify his own numbers. But the truth is that graph shown is a complete distortion. The true project number shown along this graph is shown with the red line. And this is the project case where the passenger demand is to increase to 273,000 by 2025 and to 365,000 by 2035. Even with a high growth scenario, it would have been as in the case of blue line. So you can see that with modernization, what it will be basically, the KV line will be brought in par with the main line in terms of passenger demand as well. Even then, even though it is the current KV line is carrying 30,000 passengers right now, keep in mind you can't compare the projected numbers against what is carrying right now, because currently it is a single track with only 8 trains running in the morning peak and 8 trains running in the evening peak, with only 3 trains running in the peak time. So this is a substandard system with a substandard signal system, 40 years old, poor quality service and infrastructure, and you are going to compare this 30,000 demand against a system that where we would expect to run 12 trains, almost 12 trains per hour, and by giving the necessary boost, what the model is showing is that the passengers will come in big numbers. Unfortunately, presenter has tried to create this doubt to the audience by using made up numbers and in a distorted graph. But the reality is he has been exposed himself and failed miserably. I actually would challenge him to prove that I am wrong if he can. I hope anything that is not clear on demand estimation are now clear to you, all of you. Let's move on to the vertical alignment. The argument put forward by the Transport Committee of IESL was that the track should not be elevated from Maradanu to Malapalla as proposed by the consultants. And instead, they proposed elevation of 4 sections, basically elevation over 6 roads to a length of 6 kilometers. The seminar was when we also saw this proposal first. But no details, no calculations, nor the basis for the proposed alternative design is unknown to this very day. I'm sure if you ask even today, you will not get any answer. However, our team of engineers, mainly local experts with railway engineering knowledge, and the consultants team went on and reviewed the sections that they have proposed to elevate. The consultant looked in detail based on design standards, curve radius, the track, station location, and all the other factors such as crossovers, etc. The main question we had when reviewing was to check whether their proposal was technically correct or whether it is practical. We expected, coming from a group of chartered engineers and some being railway engineers themselves, that they would have a sound base for their claims. To estimate a distance of elevation, you need to know at least 2 parameters: the clear height of the elevated section and the ramp gradient. These are essential. So we asked this whole group at one of our one-to-one meetings at the Finance Ministry for their assumptions. Unfortunately, they had no idea and no answer, even that it was needed. Their reply was that they had not looked into them in this detail. So later you will find that they had not even considered a clear height, and their ramp gradient is whopping 3%. We all know that you need to provide at least 10 meters clear length at elevation sections, and the gradient cannot be more than 1 to 1.5% for railways. Sad, isn't it? I will walk through you all why their proposal of 6 kilometer length is practically impossible and technically incorrect. So let's start with the Kota Road section, where they propose a 1.15 kilometer of elevated section. This elevated section comprises of 340 meters of a section of a total elevation and a 400 meter up ramp and a 340 meters down ramp. First, we found out that they had considered the only elevating based on clearing the roads. But the location being close to a station, the elevated section had to be 767 meters instead to include crossovers and curvatures. Then number 2, we found that the ramp length was based on a 3% gradient, which a railway cannot run on. Therefore, the ramp length they had considered were too short. Therefore, the up ramp should be 600 meters instead of 400 meters. And the down ramp should be 780 meters instead of 340 meters considered. Right. Then the assumed 1.15 kilometer elevated length is technically not possible. Instead, a 2.15 kilometer length is needed. And this also created further problem now, because the down ramp came right in the middle of the golf course. Also, 2 other locations, Leslie Rangala Mawatha and the Palpola Vipassi Mawatha, have to be closed in this case because the ramp section is halfway across this road. So vehicles cannot pass through these roads at the ramp sections. At Narayanpeta, it's a similar story. They had considered the ramp gradient high, and instead of 1.43 kilometers they have assumed you required 1.83 kilometers to be technically sound. At Nugegoda also, it's a very similar story. What they had proposed was to use a 340 meters of length as total elevated section, and a 400 meters and a 320 meter ramp length. Once again, there's a station at this section, and being at a curve section, the length of elevated section required is 780 meters instead. And also it required longer ramp length because they have considered the 3% gradient, and also because of the geometry and being at a curved section. So therefore, instead of 0.98 kilometers, you have technically you require 2.69 kilometers. And it also brought further problems with the down ramp coming right in the middle of the Mirihana road, which is one of the widely used roads at the moment. And the section between Navin and Maharagama, so they have got the elevated length correctly here of 1.6 kilometers, but the ramp section is it's too short. So instead of 2.44 kilometers that they have proposed, technically you require 4.4 kilometers. So when you summarize what they have told and our review, we find instead of 6 kilometers proposed to elevate these 4 sections, you will technically require 11 kilometers of elevation. So therefore we can conclude their proposed 6 kilometer track elevation is practically and technically incorrect. We then try to understand what is the basis for them to propose these sections or the 4 sections and why they have selected these roads to be grade separated. The question we had was whether the selection was based on the road traffic. So we look at the 4 sections separately and review the ADT of the daily traffic of all the roads that they have proposed to grade separate. You could see that they had recommended to elevate the Ruhunukala road at the Kota road section having 11,000 vehicles per day. And also on the Narhampita section, they have recommended to elevate at Dabare Mawatha and Kirimandala Mawatha having close to 23,000 and 21,000 daily traffic. But we could not find any consistency since there were many more roads having more daily traffic that they have not recommended to elevate. For example, Dimantha road having more than 45,000 vehicles, Lesirangala Mawatha having 31,500 vehicles, DM Kolobage Mawatha having more than 21,000 vehicles, Mirihana road having 21,000 vehicles, Panipitiya Malabe road having more than 17,500 vehicles, Kottawa Athurugiriya road having more than close to 30,000 vehicles were not suggested to be elevated. So we didn't know what their proposal was. Are they suggesting to control it by gates? And more we tried to find a scientific reason, more we found out that these suggestions were all based on their opinion, not based on a scientific reasoning. Now I will explain to you what we considered when we decided on elevation. First, we considered that there are 148 railway crossings from Maradana to Abhisavela, and out of that 75 crossings were up to Padukka, and there were 56 railway crossings up to Homagama with 20 major crossings that had more than 12,000 vehicles per day surveyed in 2017. And we also did a scientific approach to evaluate the delays at major road crossings that will be presented to you later on. And we also considered that some of the roads where the railway crossings are close to the main road, such as Kirimandala Mawatha, Narahempita, Dabare Mawatha, Mirihana road, etc., which will not allow elevating the road as an option. We also considered that the additional benefit of utilizing the space underneath the elevator structure we use as walking paths, cycling paths, public space, and revenue generation commercial activities. We also considered the impact of community separation, because when you have electrification, you will have to fence the whole track. So when you're going on ground, you will have to fence along the whole total length. So with that, the whole community will be separated. So we have considered that impact. We have also considered the safety impacts. So we have considered the social issues due to land acquisition and resettlement that will require additional cost and with going on ground, explained to you later in detail. And finally, we considered that, and we found that although IESL says that their proposed for going at ground with 6 kilometer elevator is only going to cost 940 million US dollars. We have found that when we consider their proposal with technical correct design and considering safety factors, it will be a construction cost of 1.4 billion, not 940 million. And this is 200 million US dollars more than the construction cost of elevated option. So, their proposal is even higher than going elevated. There are other issues that will be created by going at grade across a highly urbanized area. Going at grade will require you a higher right of way. That is, the right of way required going at ground will be 14.2 meters, while when going elevated, the right of way is 12.5 meters. So at the moment, we have a right of way of 6.5 meters. So this additional 2 meter needed extra due to going at grade will create more problems. One problem is when we go at grade, 9 kilometers of parallel roads such as shown here, Pangiriwatta Road, Purvarama Road and the famous Railway Avenue will have to be acquired to the right of way. All the houses that have access to their homes through these roads will not have an alternate access, and thus we will have to acquire them and resettle as well. Therefore, 9 kilometers of such roads that will have this kind of an impact. Another problem is with the current design. The station is elevated level above the track with ground level available for parking, drop-off, bus touch and go areas. But with at grade option, you will need additional space for station and parking as shown in this picture. Now getting back to the scientific approach we use to evaluate the impact due to grade closures. We used two methods. One was based on vehicle flow and the other was based on the UN criteria for train vehicle units. For the vehicle flow method, we use micro-simulation software to simulate what will happen to the road network when a train passes and the gate is closed. We vary the train frequency and the traffic flow to see the impact. The model was calibrated using the information at baseline road when at present the gate is closed for between 2 to 3 minutes each time a train passes, and that is with a single track. The current queue length at the peak time flow rate was about 440 meter queue length, and this is with a per lane flow rate of 1300 vehicles per lane. We simulated the future gate closures with 2 minutes, considering the gate will have to be closed in average when trains are operating both directions at high frequency. So you could see that what we have found was at when the current traffic rate, the queue length will be about 625 meters when the trains are operating at 10-minute intervals. And if we go to further frequency or higher frequency of 5 minutes, the queue length will be about 825 meters. And when you consider the future traffic flow, this will increase to more than 1 kilometer queue length when the trains are operating at 5-minute frequency. Therefore, we found that from fuel simulation that there will be considerable impact on the road network. Almost all 56 locations up to Homagama. We surveyed each location of the road crossings and we checked each location based on the observed ADT surveyed in 2017 and calculated the peak hour flow. And that because the peak hour flow is the most important when you are looking at the railroad conflict. And then we calculated the flow per lane in that peak time. And then based on that, we found each of the locations up to Malapalla will need grade separation. And the grade separation means it will need either the rail elevation or the road elevation. And when you consider that all the locations that continuously needs elevation, it makes sense to elevate the railway. The second method was to use the UN criteria of train vehicle units, or what we call TVU, and the criteria was if it is more than 100,000, these locations had to be grade separators. And based on that calculation as well, what we found is up to Malapalla, the grade separation was required. So you could see that we have used multiple criteria and consistent methods for our recommendation, unlike ad hoc way of what has been proposed by the Transport Committee of the IESL. Recently, I have heard about concerns raised by the group that elevation will increase the total time of a passenger, since they have to walk 7 meters high and come down 7 meters. And also comments such as the person carrying a coconut or a pole malla will have to climb stairs with elevation. What I want to show is actually at present the passengers would climb 7 meters up and 7 meters down where they want to go across to the platform. They do it with overhead bridges, and this is very common in railway stations. So, this argument, the people who make these arguments maybe doesn't know that in railway stations you have these kind of passenger overhead bridges. The model considers the overall access time, wait time, all in its analysis. The argument from the group gets funnier and funnier each time. According to the argument, no one should build other than single-story houses or work in multi-story buildings, since the time now increases by going from downstairs, right? Or going to their offices, which is multi-story. So I really find this very humorous. To summarize the vertical alignment option, IESL proposed that instead of elevating, only 6 kilometers can be elevated, and the profile as shown below. What we found was that it was technically flawed, with 3% gradient being considered, that it would have been like a roller coaster railway. We also found that instead of 6 kilometers, it will actually require 11 kilometers more for a technical correct design, but we'll have many more problems created because of only 10 roads crossings will be addressed. Then what we also find that in their design would actually cost 200 million US dollars more. And this will also happen, we'll need more acquisition, and they will also separate the community, and also the land underneath will be wasted. And when we consider a more scientific approach, we found that the best technical and feasible option and the least cost option would be going elevated. Let's move on to the horizontal alignment. The presenter, when he spoke about the horizontal alignment, he said that the new alignment will not have any curve straighten, and it will be like the serpent running across, and with elevation it will never be able to straighten. What was not shared with you all was that in fact the curves are straightened to some extent, to which does not need or acquisition. And the second, he did not mention what would be the advantage or benefit of straightening. I will try to answer those questions. It is obvious the best case scenario would be if the rail line is as straight as possible. In fact, the best alignment would be if we draw a line between Maradan and Avisavela and start acquiring land. And if land acquisition is not a problem. But it is not the case when the alignments are selected. You need to consider multiple criteria such as cost, the speeds you will gain, connectivity, acquisition, social impacts, etc. So as you can see in this picture, you here shown on one of the sections near Kota Road and the Parliament Road, you can see that it's going through a highly urbanized area. And this picture the pictures of the full length can be seen in the feasibility report, which is available on the csrp.lk website. The study team looked at three options. The first option is shown in red color, is the current selected trace, where the curves are maintained at 120 meter radius, with curves corrected as much as possible within the existing right of way. So when someone says the curves are not corrected at all, it is incorrect and misinformation provided. So let's look at the second option. Option 2, shown in green color, is with curves corrected up to 300 meters, And option 3 shown in blue color is with curves corrected up to 400 meters, which is virtually making a straight line as possible. As you see, both option 2 and option 3 have major acquisition involved, considering that the line would go through highly urbanized areas. I have heard people saying that it is a matter of acquiring people living in encroached land, but you can see that it is not true, and these statements are made to mislead people. If you compare the three options, option 1 can have a maximum speed of about 40 kilometers per hour in sections in 120-meter radius, where option 2 can have a maximum speed of 70 kilometers per hour, and option 3 can have a maximum speed of 80 kilometers per hour. But option 1 will require about 29,000 square meters of acquisition with a cost around 8.5 million US dollars. Option 2, in the other hand, will require 110,000 square meters of acquisition with a cost about 32 million US dollars, and option 3 will need about 172,000 square meters of acquisition with a total estimated cost of around 50 million US dollars. And mind you, this cost is only for land acquisition and will have extra costs for resettlement and other costs. So when you compare the options, we will see that there's no advantage in going to option 3 that straighten the curves by spending over 41 million US dollars more, because you don't get any benefit of the increased speed. What you see is that option 1 will get you a time saving about 26.4 minutes compared to now, and straightening will only get a time saving of 31.8 minutes saving. So virtually a 5-minute extra saving by straightening the curves by spending over 41 million US dollars, and with many inconvenience to public plus maybe lengthy legal battles. But you would wonder and think why there is no speed increase with the straightening. The reason is the first section has stations very close to each other, between 0.6 to 1.5 kilometers, when basically what it does not allow a train to achieve maximum speed possible, and even with the straightening. That is because before you can accelerate to the maximum speed, you need to decelerate again to stop at the next station. There were mentions about freight movement as well, that by elevating we will not able to transport freight. First, we need to see whether there is a demand now or in the future for freight in this line. What we found from studies are that there are no such demand. In fact, there is only 2% of total freight handled by railway at the moment, and 98% of that transport by rail are cement inputs and oil products. Anyway, up to Homagama, there are no demand for container movements, and if it does, short-haul container movements through rail is not economical anyways. Further, if a need arises, the current design allows container movement along the elevated section. Then that should not be any restriction to carry parcels delivered at the moment as well. Further, there is no need to elevate the containers up to the elevated structure. If required, facilities can be provided to access the container yards if necessary. Further, long-haul freight movement to Avisavela is planned through a new line proposed through Kelani, Koskama and Avisavela. In conclusion, I have explained to you the misinterpretation behind the story of multiple feasibility reports, and would like to confirm that there's only one final feasibility report submitted in April 2019. I have also explained how the presenter misinterpreted and misinformed you about the project cost. I have also explained how he has misinterpreted the demand numbers and explained to you the reasons the numbers have changed based on alternate scenarios. And I have shown the inconsistency in the past work of the presenter who is accusing for the demand. I also explained what the consultants have considered for the vertical alignment and the decision on elevation of the track, while highlighting the technical flaws of the alternative proposed by IESL and that their proposal would cost $200 million extra. I have also explained the option considered for horizontal alignment, and the reasons for selecting the current proposed alignment. Unfortunately, what I have explained to you have been explained to the presenters and the IESL Transport Committee since January 2019, over and over again. My question to you is, if you had listened without prejudice and able to understand the justification given, why this group keeps on repeating the same thing over and over again? How ethical was it for them to make a confidential document public disregarding code of conduct of being in the steering committee? How ethical it is for them to go and write to the ADB? And in the first instance, it was their steering committee member who did not attend the steering committee meetings when these crucial decisions of elevating that is the vertical alignment or the horizontal alignment and the cost, all these were discussed. Can a group who had objected and tried to sabotage the expressway construction and even held workshop the day before opening of the expressway saying similar lobbying can be trusted? I think the history is repeating now in public transport side of the transport sector. Can there be any other motives behind this continued lobbying, where a group, when they are not involved in a project, comes and make this kind of lobbying? I think I have given enough information for you to think, and it's over to you to decide. I will leave you with a quote by W. Clement Stone, where he says, "The truth will always be truth, regardless of lack of understanding, disbelief, or ignorance." Thank you for listening.